Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge Dota2 Senate. So in this question here, whatever is given here, that is just a story which we don't need to check that it is essential or not. But after that, here's the main question which starts is this particular thing. Now let us first read this question, then about the constraint, then let us check about the inputs and output which are being given to us, means basically the test cases which are being given to us, and then finally the coding part for the same. Now here, given a string Senate representing each senator's party belonging, the character R and the D represent the radiant party and the dire party. Then if there are n senators, the size of the given string will be n. And here with the size n, it simply represents that there are n chances. Then the round-based procedure starts from the first senator to the last senator in the given order. This procedure will last until the end of the voting. All the senators who have lost their rights will be skipped during this process. And suppose every senator is smart enough and will play the best strategy for his own party, predict which party will finally announce a victory and change the Dota to game. The output should be radiant or dark. So basically in this question, whatever string is being given to us, in that it would be represented by R and D characters that simply represent that R is for the radian and D for the dial. And then now the thing is, uh, let us first check for constraint, then I'll go ahead. So n is init length and it could be up to 10 raised to power 4. So if n square solution is there, then it won't work because that will result in 10 raised to power 8 times complexity. So here n log n solution can only work, and then Senator Y is R or D. Now, here in this first example, R and D is given to us, right? And answer is radiant. And how it is radiant? The thing is that when R comes, right, and then D is also there. So now, as per the question, whatever comes first, and if there is only two chances there, means as per the string length, there are just two chances, and chances would be given, means first to the radian, then to the diode, first to the diode, or then to the radian. Then here is a simple strategy that radian can completely eliminate the rights for voting for diode. So that's why in that context, radiant is our answer. Then when it comes for the RDD, so here at the first moment, Radiant can eliminate the voting right for that, but that was just for that particular uh, candidate, right? After that, that again comes, right? Until now, here we were having till now having Radiant, but that again comes up, and that have two chances, and because of coming up with the two chances here, and Radiant was having just one chance, so because of that thing only Dire wins. So like this whole question goes on. So let me uh, give you the pictorial view of the same. So here input is a string and output would also be a string. So if RD is there, then the answer would be radiant. How it would be radiant? Here you can clearly see this R which is there, right? So first it comes at the minimum position it is there, and then dire comes, right? So here radiant can easily uh, eliminate the voting rights for the dire. That's the thing here. And then we have further more chances for radiant and more chances for die. In that context also, radiant again can eliminate the chances for die. So that's why radiant is our answer. Then here in RDD, dire wins. And how it wins? Radiant. Although eliminated the chances for dire, but still dire have one more chance. So because of that thing only, it wins. Now here we know that dire is the answer. Here the answer would be radiant because radiant have two chances, and because of those two chances it can easily eliminate the dire. And here radiant has one chance, dire has one chance, and whatever is at the minimum position, because of that thing only it has the first chance, and because of first chance it can easily eliminate the voting rights for the other one. And that's why radiant wins. Here radiant, dire, radiant, again radiant will win. So now from these examples, means basically there is one observation, and that observation is that whosoever is at the minimum position, and then further, how many chances that particular have, according to that only, that particular wins. So this is how we need to code this particular solution. Basically, this is a greedy solution where we are required to have the local minima and local maxima, and according to that, we are required to go ahead with the global minima or maxima. So that thing would be how we can do that. That's the first question. In context to if we use some data structure, then it will ease out our process. So now comes the part that which data structure we will be using. So here, because we need to first push whatever is minimum at this particular point, and then add up the chances which are possible for that particular gradient or diet. And then again, we need to check for the next turn. So it is like first in, first out process, right? So in that context, we will be using a queue. Basically, we will be using two queues, and those two queues would be like one for the gradient and other one for the diet. So that how we will be required to do. So let me show you a few examples before coding the solution. So here, the length of the string simply gives the number of chances. That is the thing. So here, if we take this RD as the example, so first queue is for the radiant and the second queue is for the diet. So here, the radiant is at the position 0 and diet is at the position 1. So minimum out of them is 0, right? But the thing is that we also need to add up how many chances a particular person have. So that chances is simply the length of the string. So that's why we will be eliminating both of them and then adding up the means 0 would be added with 2 as 2 is the length of the string, and then finally whichever queue has the maximum number, or you can say whichever